Hello everybody, welcome to mathskpreet. Hope you all are doing fine. Today I am taking topic real numbers. This is chapter number 1 of grade 10. In the last standard in grade 9 we have seen the number system, a full chapter. Chapter number 1 was it. In that chapter we have seen the definitions of different types of numbers and the related questions. So in this chapter we'll see a very important theorem known as Fundamental Theorem of Arithmetic. What this theorem says? This theorem is saying that every composite number, so we know what a composite number and prime numbers. Prime numbers are basically the numbers that have only two factors, that number itself and 1. And composite numbers are the numbers that are not prime. Means that the numbers that have more than two factors. More than two factor means the factor other than itself and 1. So every composite number can be expressed as the product of primes. This theorem is saying that every composite number, we can express every composite number as the product of primes, and this prime factorization is unique apart from the order in which prime factors occur. So this factorization is always unique when we put all the factors in the ascending order. This is the mean that order doesn't matter, but if we put all the factors in ascending order, we will get the unique factorization of that number. For example, say if I am taking number 156. Clearly this is a number that has more than two factors, that has factors other than 156 in 1. Why? Because it is ending at 6, so at least it is going on 2. So if I do prime factorization for this number, 2 7s are 14, 2 8s are 16, 2 3s are 6, 2 9s are 18, 3 1s are 3, 3 3s are 9. This is going on 13 only. Why? Because 13 is a prime number. So prime factorization for 156 is what? 2 into 2 into 3 into 13. This is the prime factorization and it is unique for this composite number. How? If somebody write it like 3 into 2 into 13 into 2. So this line means this is unique apart from the order. So order doesn't matter in which prime factors occur. Factors should be same, but the order doesn't matter. So it is basically unique. By changing the order, the factors will not change, or the presentation of the 156 will not get affected. Fine. This is the meaning of this uniqueness. So if I in this order, these factors are in ascending order. 2 is the smallest prime number, then we are getting 3, then 13. If we express the factorization in ascending orders of the primes, we will get the unique representation for the factorization of composite numbers. So here I am taking few questions from exercise 1.1, which is quite easy. Why? Because we have seen how to perform the HCF and LCM of two or more numbers and how to calculate how to factorize a number into primes. We have seen all these concepts in the lower standards. So questions are more related to these three concepts: HCF, LCM and prime factorization. So the question number 1, I am just doing the first part of it. Express 140 as the product of primes. This question is very simple. We can do the prime factorization of 140. 2 7s are 235, 5 7s are 35, and 7 1s are. So the prime factorization for 140 is 2 into 2 into 5 into 7 into 1. So this can be written as 2 square into 5 into 7. This expression is unique according to the fundamental theorem of arithmetic. Why? Because 140 is a composite number and we can express every composite number into the product of primes, which is always that presentation is always unique. So we have to perform all the parts in the question number 1 like this only. It's very simple. So the next concept is saying that product of HCF and LCM for the two numbers is always equals to the product of that numbers for which we are calculating the HCF and LCM. So it's saying that LCM of P1, P2 multiplying it with HCF of P1, P2 will always be equal to the product of the that numbers. So as I have told you in other videos as well, if we have any one thing from this LCM or HCF and two numbers, we can calculate the missing one. So the question number 2 is saying that, I'm just doing the first part of it. It's saying that find LCM and HCF of 26 and 91 and verify this result. So for 26 I can write 26 as and 91 as. Let's see the prime factorization for 26. 26 is 2 ones are 2, 2 threes are 6, that's it. 91 is 7 ones are 7, 7 threes are 21. So here prime factorization for 26 is 2 into 13 into 1, and here 91 can be expressed as 7 into 13 into 1. So we all know that HCF is what? HCF is minimum power of the common factor. So here common factor is what? 13 only. So HCF is 13 for these two numbers, and LCM is what? Maximum power of all the factors. So all the factors is 2 and 7 and 13. Maximum power of 13 is what? 1 here. So the value is 182. Let's verify this result, whether this is holding or not, whether we have calculated the HCF and LCM correct or not. So it's saying that LCM into HCF will be equals to product of the numbers. Numbers are 26 and 91. LCM is 13 and HCF is 182. It is 26 and 91. So let's see whether this product is giving us the same answer or not. These I'm getting 2, 3, 6, 6 on both the sides, so we can write hence verified. So you will write, we know that HCF of two numbers, say n1 n2, its product with the LCM of the same numbers will be equals to the product of the numbers. This result we have. So here our n1 is what? 306 and n2 is what? 657. So we'll put the values HCF of 306 and 657 into LCM for the same numbers again will be equals to product of the numbers. So HCF is given to us, that is 9. Put the value here. LCM we have to calculate here, so keep it as such. This will be equals to 306 into 657. Keep it on the left hand side. Take this 9 in the denominator. So I'm cancelling this on 3. Again this 3 2s are 6, 3 1s are 3, 3 9s are 27. So in the numerator I'm just getting 102 into 219. So it's 102 multiplying with 219. So after multiplication you will get your answer, that will be equals to 22338. 22338. So this is my answer for what? For the LCM of the same numbers. This is how we have to perform this question through the result. This result basically just hold for the two numbers only, where we have to calculate the LCM or HCF for the three numbers. This result will not hold or may not hold. So the question number 5 is very important and good question it is. It is asking, check whether 6 raised to power n, where n is a natural number. So 6 raised to power n can end with a digit 0, the digit 0 or not. So let's assume that 6 raised to power is ending with 0. In such type of questions, we will assume the thing that we have to prove. So assume that thing first. So if this number is ending with 0, any number which is ending with 0 is always divisible by 5. So therefore, or so, 6 raised to power n is divisible by 5. This is the divisibility rule for 5. So 5 will divide that number, means 5 will divide 6 raised to power n. But we know that 6 raised to power n can be written as, 6 can be expressed as the product of two primes, that are 2 into 3. So 2 into 3 is 6. Keep this power n as it is. So we can express this 6 as 2 into 3. There is no 5 in the prime factorization of 6. So if 5 is dividing 6 raised to power n for any natural n, that means that 5 will be a factor of 6 raised to power n. But here we can clearly see that there is no such 5 which is a factor of 6 raised to power n. So this thing is contradicting our assumption. So we will write which is contradicting our assumption. So we are contradicting the assumption. Therefore, 6 raised to power n cannot be ANDed with the digit 0 for any n belongs to capital N. This is how you have to perform this question. So a similar example is also given in the book, that is asking us check whether 4 raised to power n can be expressed with the digit 0 for any natural. So we know that 4 raised to power n can be written as, this 4 can be written as 2 into 2 raised to power n, which is basically 2 raised to power square then n. We can multiply these exponents. We have studied the laws of exponent in the grade 9. So this 4 raised to power n can be written as 2 raised to power 2n. There is no such 5 because till here question is same. We will just assume that then 4 raised to power n will be divisible by 5. But in this expression there is no such 5 in the factorization. Therefore this thing is contradicting our assumption. Therefore 4 raised to power n cannot be and with the digit 0. Question number 6, it is asking explain why this number is a composite number. So what is the definition for a composite number? That it has more than 2 factors. It has factors other than 1 and itself. That numbers are composite numbers. So let's check why it is a composite number. So the given number is, write the number. This is the given number. So this is multiplication, then plus, then 13 we have. So we can take this 13 out from this addition. So we are left with 7 into 11 into 1 plus 1 here. So this can be written as 7 into 11 is 77. This is plus 1. So I am getting 13 into 78. Fine. We can factorize, 13 is just a prime number. We can factorize 78 into primes. So 2 3s are 6, 2 9s are 18. Then 3 1s are 3, 3 3s are 9. So this can be written as 13 into 2 into 3 into 13, which is basically 2 into 3 into 13 square. So this is the prime factorization for the given number. Fine. So the given number can be expressed as this. This is prime factorization. So clearly this number has more than 2 factors, the number itself and 1. So these are the factors of the given number. So therefore by definition this number is a composite number. So we can write it like, clearly given number has more than 2 factors. Right? It was very clear from here also. So given number has more than 2 factors, therefore it is a composite number. Proved or explained. Fine. This is the next part. This is the other part that is given along with the same question. Here also we can take 5 out from this addition and we are left with 7 into 6 into 3 into 4 into 2 into 1 plus. So this number is multiplication of 2 numbers which are basically factors of the given number. You can express this number as the prime factorization. So ultimately you are getting the prime factors for this number other than itself and 1. So this number is also a composite number. I hope you understood. Let's see the next question. 7. It is saying that there is a sports field, circular sports field, and 2 persons, Sonia and Ravi. Sonia takes 18 minutes for 1 round if she is starting from here, and if Ravi is starting from the same position, he is taking 12 minutes to cover single round of this circular field. So they are starting from the same position and going in the same direction, and to cover single round they are taking 18 minutes and 12 minutes. Fine. The question is asking after how many minutes will they meet at the starting point. Fine. So we need to check the minutes where they will meet for the first time. We all know that when we have 2 numbers, the HCF will always give us some divisor. Okay, HCF is related to factor. Factor means HCF, highest common factor. Factor means divisor. And LCM is what? LCM is the value of dividend. Which dividend? Least common multiple. This is related to dividend. Also HCF is what? HCF is minimum power of the common factors. So minimum power of the common factors of these we have to calculate. That means we will get some lower value, because we are calculating minimum powers of the common factors only. And LCM is what? LCM is always maximum powers of all the factors. Here we are considering all the factors, along with that we are considering the maximum power of all the factors. So here we will get greater value as compared to the HCF. Fine. So LCM is giving us the greater value always, and HCF is giving us the lower value always as compared to each other. And HCF is related to divisor. LCM is always related to dividends. So this Sonia is completing one round in 18 minutes. Fine. Sonia in 18 minutes and Ravi in 12 minutes. Clear? So we need to check when they are meeting after the rounds, after how many minutes they are meeting. So after how many minutes, that means that they will cover some distance. Both will cover some distance. They cannot meet at this situation. Fine. They cannot meet at lower than this situation, these number of minutes. So to calculate the thing that is greater than or more than these 2 minutes, we will check what? LCM here. Let me check the LCM and HCF for these two numbers. So if this is my number 18 and 12, so factors are 2 into 3 into 3. Here factors are what? 2 into 2 into 3. So fine. 2 3s are 6, 6 1 6 are 18. Fine. 2 to the 4 4 12. Fine. So the LCM HCF is here what? Minimum power of the common factors. What are the common factors? 2 and 3, and minimum power of 2 is 2 and 3 is 3. Fine. This is HCF. And LCM is what? LCM is maximum power of all the factors. Maximum power of 2 is square and 3 is a square. So I am getting 2 square into 3 square, which is basically 4 9s are 36. Fine. So I am just trying to clear you the concept why I need to check LCM here. As I have told you, we need to check after how many minutes they will meet. Obviously they will meet after some rounds. After some rounds we will get minutes that will be more than 18 and 12. So if we need to get the value that is more than the given value, that means in that questions we have to check the LCM only. And to get the lower value where the result could be lower than the given values, and in that questions we can check the HCF. So this question, such type of questions are related to LCM only. The other way to understand is in one round Ravi and Sonia. Fine. Sonia is covering in 18 minutes. So 18. Fine. In one round he is taking 12 minutes for one round. For the second round she will take 18 more minutes. For the second round he will take 12 more minutes. This is what? 36. If I add up these two values, I am getting 24. Fine. To meet this 36, I need to add one more 12 into it. So I'll get 36 here. That means Ravi will take 3 rounds and Sonia will take 2 rounds when they will meet after 36 minutes. This is one way to check, but we must know about the concept of the LCM and HCF. LCM is always related to dividend, the more value, the greater value as compared to HCF, and HCF is always related to the divisor. So in this question we need to get minutes that are greater than these 2 minutes. So we will calculate the LCM here. I hope you understood. The answer is 36 here. So these were all 7 questions from exercise 1.1. I hope you understood each and every step related to the solutions of the problems. And I hope you are able to do the rest of the parts of the questions by yourself. Hit like if you are liking my videos. Please do share my content with your friends and mates. Subscribe for more, and thank you for watching. Have a good day.